All right, so we are doing rigid transformations, and this is target 6B. Again, nothing that's too terribly difficult, but you'll be fine with it. All right, so first things first, you have to identify transformations. There are three types. There are reflections, rotations, or translations. So basically, if a slide translation, you're just moving it. You're basically just taking the object and moving it. So imagine if it was something on a table and you put your hand on it and just kept it facing the same way. Okay, didn't change anything about it, and then just moved it around. So a slide can go left, right, or up, down. There are rotations, which you actually like. If you took, like, say, your phone on a table and you put your hand on top of it and twisted your wrist, that would be a rotation, along with kind of moving it. If it's rotated about a point, that would be like the hands of a clock. We'll get into that later, though. Just understand a rotation is rotation. And then a reflection is pretty self-explanatory. If you drew a line like this right here, okay, like this, and then you had an object, basically imagine this is a mirror and this is what it would look like in the mirror. All right, so the new figure is the image and the original figure is pre-image. Okay, the operation that moves the image is called the transformation. So I've got, my favorite superhero, Superman. I decided to use his shield to kind of help identify this. So we have a reflection, we have a translation, and we have a rotation. So let's start with the reflection. Again, remember I said it kind of flips over. So if I do this right, it'll look like that. So it'll look like a backwards symbol, and that will be the transformed image. A translation would be if you take it and you just slide it across, and that would be the transformed image. And then for rotation, now this is rotated about this point. So if I said to rotate this image about point A, okay, I would basically take my original and I would rotate it, and that would be the transformed image. Now, if I just said to rotate it, you would just take it and in place and you would spin it. So like if I said rotate it 180 degrees, it would be upside down like this, and your Superman symbol would be like that. Okay, so that would be just if you rotated it in place in the center. All right, so hopefully that makes sense to you. If not, we will go over it. So to identify transformations, again, a reflection would be is if this was the line of reflection. Translation, basically, if you picked a point, about the same point on each one, we moved it right and then down. And rotation, if we just took this image and rotated it, it would look like that. Okay, so that's kind of what I was talking about before, not rotated about a point, but rotated about the center. All right, so now you'll often see things as in this format where you've got A and then you've got A with this apostrophe. That means A prime, and then B, B prime, C, and C prime. What this is this is the original image. Okay. This is the transformed image. Okay, so this is where you're starting, this is where you're finishing. That's basically what that means. So now we're just going to work on describing the transformation. So this tells us that this arrow tells us, okay, we're starting here at this one, and we're going to finish at this one. So, and we know it moved 2 feet to the right, okay, and then it moved 1 foot up. So from here it moved 2 right and 1 up. Because remember I said it goes right, left, up, or down. Okay, in this one, so this tells us, now notice it just says determine the type of transformations that took place. So how do I know where to start? Well, I can see that this says I've got an A prime, a B prime, and a C prime. So that means that this is the new image or the ending point. This is the original image or the starting point. So if we were to pick a point, and it doesn't matter which one, but I'm going to go with A. So if I started here, I've got to end up here. So what did I do to get there? Well, I went down, and this is a translation because we're just sliding it. So I went down 9, and to the right, 4. See how that works? Up, down, left, right. Try this one on your own. So again, we've got ABC, triangle ABC, and triangle A prime, B prime, C prime. So I went from here to here. Not always going to have this helpful little arrow telling you which one's the original. So, again, this is just a translation. Pick a point. Doesn't matter which one. I chose, again, A. So I went up 3, right 2. See how easy that is? Here's another one. Okay, now, no A prime or B prime. It doesn't tell you which one's which, but in that case, I would start with the letter closest to the beginning of the alphabet. So I would go A, and then B would be like the where I'm ending. So go down, because I picked this point here, which means I'm going to have to look at this point here. So I went down 3 and right 7. All right, so now you're going to actually have to perform the translation. So what does this mean? Well, you're going to have to use first off, you're going to have to use a straight edge. So, and on your paper, you should have 3 triangles by the time you are finished. So first things first, translate the given triangle 5 units down. So basically what you want to do is you want to take each one of these points and move them 5 units down. So I'd go down 1, 2, 3, 4, 5 to here. From here, down 1, 2, 3, 4, 5 to here. And from here down 1, 2, 3, 4, 5. So that'll be my other point. Connect the dots, and you have your first triangle. Second thing they want you to do is reflect it over the y-axis. So basically, since I'm reflecting it over this, I want to find out how far each point is from there. So I have to go 2 this way, which means if I have to go 2 more that way, and my point will be there. From here, 1, 2, 1, 2. And then, let me erase those so it's less confusing. From here, I have to count over 1, 2, 3, 4, 5, 6. So I've got to go over 1, 2, 3, 4, 5, 6. And that'll be my other point. And then connect the dots. There's your third triangle. So try this on your own. Just quickly sketch out that figure. Translate it 10 down. So again, you will, let me change the color so you can see it a little bit better. So 10 down would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 would be down here. This one, since they're on the same line there. And then that down 10 would be right there. Let's make sure I'm right. Yep. So that would be 10 down, reflected over the y-axis. Well, you know what? That's actually reflected over the x-axis right there. Okay, if it was reflected over the y-axis, this would look identical. So that's my bad. Sorry about that. Let's change that. So that would be reflected over the x-axis. Because remember, here's your x-axis, here's your y-axis. So if it's reflected over that axis, that's basically saying, okay, if I put a mirror there, what would it look like? So see, if I put a mirror here on this y-axis, the triangle wouldn't change. The way I labeled it would change, but the triangle itself would not. All right, so let's make sure this one's right too. Translate it 4 units up. So we will go, we've got these points here. 1, 2, 3, 4. 1, 2, 3, 4. And from A, 1, 2, 3, 4. So that triangle should be right there, and it is. Reflected over the y-axis, so this is 2 units. This is 2 units, and this is 5 units. So if I have to go 1, 2, that should be A prime. 1, 2, that would be C prime. 1, 2, 3, 4, 5, 6. Or I'm sorry, 5, not 6. And that would be B prime. And if I did it all right, bam, all good. All right, so this one going to look a little bit more confusing because this triangle is not a perfect shape, not equilateral like you might be used to. So start off 8 down. So pick your 3 points. Count down 8. 1, 2, 3, 4, 5, 6, 7, 8. That one's on the same spot. So 1, 2, 3, 4, 5, 6, 7, 8. So that would be translated down 8. Reflected over the x-axis, same as we've done before. All right, and that's it for transformation, rigid transformations. If you have any questions, write them down. Ask me during class, please. Do not hesitate. I don't want you guys getting lost.